Hello, everyone, and welcome back to the Cisco Optics Podcast, where we talk about pluggable optics for networks. Multi-modeFiber has been the workhorse for fiber optic communication within a data center for years, as well as a choice for Ethernet backbones in office buildings. It has a rich history that goes all the way back to the first optical fiber standards when 100 megabits per second was a huge data rate. Anybody remember those days? This is episode 52, and we begin a new conversation with Hao Dong, Market Technology Development Manager for Corning's optical communications business. We begin with his start in semiconductor lasers for telecom before switching to fiber lasers. Hao Dong is a Market Technology Development Manager for Corning's optical communications business. Within this role, he focuses on technology and market trends to identify, evaluate, and develop leading optical network solutions that form the backbone of today's connected world. Hao has over 18 years of industry experience and has held various positions in engineering, development, and marketing within the fields of optical components, fiber lasers, and optical communications. Hao holds a Bachelor of Science in Physics from Wuhan University and a PhD in Physics from the University of Connecticut. And now join me as I talk with Hao Dong. Hey, Hao, how are you doing today?
Yeah, I'm good. How are you, Pat?
Good, thanks. So, thanks for joining us. I know you're very busy. I'd like to start just hearing you tell us about your journey in optics, how you got into it, what you had been working on, what you're doing lately. Anywhere you'd like to start.
Yeah, sure, of course. I actually started working in the industry. I think about 15, 16 years ago. I got my first job as a product engineer in a semiconductor laser company in New Jersey, actually. That was back, several years after the telecom bubble was gone, right? So the industry at that time was really slowing, picking up.
So you missed the telecom bubble bursting, or did you
yeah,
experience
fortunately
that?
at that time I was still at school, so
Okay.
when I started everything, it's like I said, the industry is was slowly picking up. Many countries was getting ready to deploy 3G, and it seemed like um, people were needing more and more fiber and lasers at that time. So
Okay. Wow.
yeah,
3G. Who can remember
that's
that
right.
was once the hot new thing?
Yeah. But that's I would say that's the starting phase of the fiber to the home deployment, right? I still remember at that time I live in New Jersey, and the people, we really switched to, and totally you can see it makes a difference. So that's the first time we really, for real, started enjoying the convenience fiber bring to us. Yeah. So work-wise, like I said, I was happy. I choose the telecom industry as my starting as my first job. I working for the semiconductor laser company. At that time, we were making a 10G EML and TOSA. My job at that time was really working in the floor and very technical, working with the technicians and engineerings, troubleshooting any possible optical issues we came across almost on a daily basis, right?
So you were doing the actual fabrication on site of the semiconductor, or did you have like
yes. Mhm.
Go ahead.
Yeah. At that time, this the company, I think basically we did a two part of the work. One is to use the MOCVD to grow the chips, and then packaging the chip together. We call it the front end and back end, right? You know the difference.
Actually, no. Explain that to me, please.
Yeah, I think for the chip making, by basically you grow the materials starting from the chemicals, right? That's what we call it the front end. And when you have the chip, you need to go through a lot of testing and environment process, right? And then eventually you make the selection and the package everything together into the diodes, the packaging stage, that's I think we call it the back end.
Okay, so the front end is what happens first, the actual fabrication of the semiconductor, and then you have to put it into what, some kind of substrate, wire bonds, I'm guessing.
Exactly. Yeah.
Okay.
I think it's called the chip on the um, um, chip on the base, or chip on the submount. Yeah.
Okay.
Yeah.
Okay, so that's all front end,
Uh-huh.
and then back end
And
is
then
the
and then as you can imagine, when you got the chip, when you package the optics together into the diode, you still have to go through a lot of the testing, and the testing is it could be very lengthy and a complicated the process, right?
Sorry, does the
So
packaging include fiber attach? Fiber coupling?
yes, yeah, it involves a lot of fiber alignment. Because
Okay.
if you imagine when you have the chip, uh, uh, if you have the chip, and then eventually your job is to launch the light out of the from the semiconductor laser
Mm-hmm.
and launch the fiber into the fiber, right? There will be a isolator in there to make sure there is no back reflection.
Mm-hmm.
And also you need to make sure you have the you have the lens system to collimate the light, right? And the
Mm-hmm.
final stage is to working on to basically to work on the alignment to make sure you have a higher alignment efficiency, which is also very important.
And that's all actively aligned, I'm guessing, where you have to measure the power and tweak as you're optimizing the power.
Yeah, there were a lot of details. Different company with different ways of doing it. You could do the positive, the active alignment or passive alignment,
Hmm.
but most likely, you will need a lot of cameras in there. Watch the
Hmm.
camera, and it's at least at that stage, at that time, the work is still very, manual and um, of course, I'm sure in these days, probably a lot of work will be done by automation.
Yeah, yeah, but at that time it was like, yeah, I also remember at that time it was very manual, very complicated, because it was a young industry, right? So the
Exactly.
automation uh, hadn't really been developed yet for that particular
Right.
process, right?
Yeah. Exactly. So yeah,
Okay.
that was my first job. It's
Oh,
uh,
sorry, I interrupted you before you got to the back end. So,
right. Right. Um,
s-
yeah. So as you can imagine, there is a lot of testing work to do, and as a product engineer, I also did a lot of testing.
hmm,
So like I said, that was my first job. I really enjoy the learning from the work. I
hmm.
learned the LabVIEW program myself. So once you
LabVIEw?
yeah, LabVIEW
Yeah,
program
yeah.
back
Oh, I
then.
love LabVIEW. Yeah.
Yeah, when you have have some idea, yeah, think about to put everything together, hooked up those equipment, write the LabVIEW program,
Hmm.
make it happen, right? So that was really satisfying for me.
Yeah, yeah. I can totally
Um,
relate.
yeah, so that's how I end up in the telecom industry. But after several years, I switched to another company. Basically, it was kind of like a 180 turn. I started working
Hmm.
on the fiber laser, so it's totally non-telecom, even though it's still fiber based. Um, yeah, so
And this was a high power fiber laser. I saw in your LinkedIn it
yeah.
was kilowatt
Uh-huh.
single mode.
Yeah, exactly. It was a kilowatt single mode CW laser. As you can imagine, it's not pulse. If it's pulsed laser, I think the kilowatt. Um, I mean the
Kilowatt
laser, the
average
fiber
average power, right?
average power. Yeah,
Yeah.
exactly. The fiber laser was for cutting and welding applications. So
Hmm.
kilowatt is typically it's a CW based laser. So
I
but
uh
in a
I
daily
used
work.
to back in my grad school days, we used to do mode locking of fiber lasers. So we would think more about the peak power. Average powers were still, less than a watt.
Yeah,
but peak
exactly.
powers were, certainly in the kilowatts.
Mm-hmm. Right, but I think probably we were talking about the same, similar stuff, doing the similar work, right? Splicing, fiber splicing, fiber processing, handling, that kind of thing. So in my daily work, I would say the most important thing is fiber splicing. You have to develop the recipes, right? Splicing recipes, and be careful of almost all the single details. People always say the devil is in the details.
Yeah.
I think it's, for me, until I started working on the fiber lasers, I really understand what does it mean by that. Because when it comes to the high power, you got to be careful with all the single details. You can't overlook some even like minor things, small details. Otherwise, catastrophic failure does happen, right? Fiber
especially
fuse, pretty scary.
At those power levels, things can melt, I guess, right?
Oh, it's a fiber
or
fuse.
At least get damaged. Or
yes,
fused?
Yes.
Okay.
When the fiber fuse happens, it's it's a total damage. So there was no way
What do you mean by fiber fuse exactly?
It's burned. The fiber, basically, the root cause of the fiber fuse is the high temperature, right? When the temperature goes much higher than the polymer coating can handle, it's not an issue for glass, right? For the glass, it's a silicon material. It's typically it can withstand a much higher temperature, but it's not the same case for the coating. For the polymer coating, when the temperature goes up to say 200 degrees C or 300 degrees C or something like that, it get burnt. So that's why you have to handle the temperature very, very carefully. The mechanical design, your thermal processing is very, very critical.
So how did you keep the polymer coating cool? Was it air cooled or any liquid cooling?
Well, there are many different ways. It depends on what you need, depends on the power level. Sometimes I think the common practice is water cool. You need the cold plate below the fiber and below the fiber plate. And also you need to package the fiber in a well-managed way, right? For example,
the thermal management?
Yeah, the fiber management, the thermal management. How do you lay the fiber on the plate? How to packaging your fiber to make sure the contact, that kind of thing. So, it's quite tricky, and there are a lot of details when it comes to the thermal management.
It's funny we're talking about this now because this is a big topic in data centers. That was the first part of my new conversation with Hao Dong. Next time, we'll get into both single-mode and multi-mode fiber. We have a new website. It's optics.podcastpage.io. You can either listen there or use the same podcast platform you've been using all along. Please subscribe. Better yet, leave a review, especially if you've been using Apple Podcast. Remember, we're part of the Cisco Podcast Network where you can find other great Cisco podcasts too. We also have educational videos on YouTube. Just go to youtube.com and search on Cisco Optics. Thank you for listening. This is Pat Chow, Product Manager at Cisco Optics. The next episode is part 2 of my conversation with Hao Dong. Until next time.